The law of conservation of momentum says this: all momentum in a system is conserved. Okay, so what in the heck does that mean? Well, first of all, what in the world is a system? Well, let's take an example here. Let's suppose that car number 1 has a momentum, and let's suppose that car number 2 has a momentum, which means the following. You will notice in the bottom of this car, I have some weights. It is a Pinewood Derby car, and the weights give it its mass, along with the wood and the wheels and everything else on it, okay? So this has a mass, and it's gonna have its own separate velocity. This car, Pinewood Derby car number 2, also has weights in it. You'll notice there are weights positioned everywhere here. So the mass of this car is probably different than the mass of the other car. Remember, mass is the number of particles. So we're talking about the wood, we're talking about the wheels, we're talking about the sticker, everything on here is made up of particles. So this is gonna have its own mass and it's gonna have its own velocity. I'm gonna take car number 1 and I'm gonna make it go relatively slow, and then I'm gonna hit it with car number 2, okay? When I do that, these 2 cars comprise a system. The whole thing together has a total momentum, and that total momentum is not going to change. So let's talk for a moment, okay? This guy right here has a mass, and it's gonna have a relatively slower speed. So it's like grandma driving in front of you and she's going really slow and you're texting on your phone and you're not paying attention and you're in this car. This car has its own mass. And as a teenage driver, you're probably gonna be driving faster than grandma is. Not only that, you were texting so you weren't paying attention, so you're gonna bump into grandma. So here's what's gonna happen. We're gonna take the mass of this times its velocity, otherwise known as MVP. We're gonna take the mass of this times its velocity, otherwise known as MVP. We're gonna take those 2 momentums and add them up, and we're gonna get the total momentum of the system before the collision. Now, according to the law of conservation of momentum, that total amount is not going to change. Now, I think you know when you come speeding up and you crash into grandma, a couple of different things could happen. We're gonna pretend this happened. We're gonna pretend you bump into grandma and grandma bounces off of you. What's gonna happen to grandma? Is the mass of her car gonna change? I don't think so. It could if she lost a bumper or something, but odds are it's probably gonna stay the same mass. So what's gonna change about grandma? Grandma's probably gonna end up going a little bit faster because you hit her, okay? What's gonna happen to you? Well, you're probably gonna lose some speed and slow down because you hit grandma. So if I take the mass and your new velocity and multiply them, and I take the mass and the new velocity of grandma and multiply those, and if I add those 2 numbers together, guess what? It's gonna equal the same thing as the beginning. The momentum is always conserved. You don't lose anything. The momentum before equals the momentum after. So here's grandma. She's going kind of slow and you ram her from behind and she went a little bit faster, but the total momentum is still the same.